I done told y'all that I record the class and I forgot to hit record. Sorry about that. So basically, y'all missed my name, right? Chris Lee. All right. So yeah, that's about it. How to sign up for tutoring, right? For me now, when it comes to office hours, right? You can book me for office hours through tutoring, right? I know some professors might say, "Oh, I have one office hour from this time to this time." Like, nah, you guys have mad hours with me, right? Just book it, right? Take as much as you want, right? I'm not sure if I'm gonna have online and in-person hours. That's up to them, but whatever happens, take advantage. Mhm. So that's tutoring and office hours. How to get there? I also want to talk about. So yeah, we're doing Math 23, probability and statistics, right? Yeah, there's a whole bunch of outlets out here. Just find one. They work in it's like an old chemistry lab, so outlets all over the place, you know? All right, so probability and statistics. So just to give you guys a little list of what we're going to be doing, right? We're going to be sorting, analyzing, and presenting numerical data using sample excuse me, measures of central tendency, measures of variation, measures of dispersion, right? We're going to recognize correlations between data sets, right? Using scatter diagrams. Those are pretty fun. Express linear correlations using least square regression, determine the strength of the correlation, right? Coefficient, lovely stuff. Predict experimental outcomes, that's going to be really fun. Permutations, combinations, counting techniques, right? We're going to do binomial experimentation over here. We're going to do normal distribution, right? Sampling distributions. We're going to do limit errors, right? All fun stuff. This is going to be a really dope class. I promise you that. Real quick, I want to show you guys where you can find the syllabus. So let me share that with you guys. I assume everybody knows how to get to the BCC website, no problem, right? All right, cool. So what you're going to do, you go over here to where it says academics. We're going to go down to where it says academic departments, right? We're going to go down to math and computer science, right? This is being recording too, so like if you're not like taking notes, it's all good, right? You go to where it says degree programs and courses. Then you're going to scroll down, all the way down. Keep going to Math 23, right? So when you're here, the first set of links, this is your syllabus. This is the review sheet for your final, but we're going to talk about that in December, right? And then this is your formula sheet right here, right? I'm going to hand this out to you next week, right? We're not going to be doing anything from the formula sheet today, you know, but I'm going to give y'all a copy next week, all right? But for right now, what we want to talk about, the syllabus right here. Go ahead. Yeah. Yeah, I'm gonna even give you a link to it in Brightspace. So yeah. But this is just in case you're wondering, like, how do you find it on the internet? This is the process that you go about to find it on the internet. You know. So this is your Math 23 syllabus. This is going to be our textbook using basic statistics by Braze and Braze 8th edition. Yippee. Right. If you guys want to get a PDF of it, that's fine. We have copies of the book in tutoring. There's copies of the book in the library in case you guys want to just rent it and read it over there. With so you don't have to buy the book. It's up to you guys, whatever you guys choose. Calculator. I highly suggest that you get this calculator, TI-36X Pro, right? TI-36X Pro. They have it at Staples. I believe last time I looked at Staples, I want to say it was like, let me think. It's Math 23, right? So it's about $23, right? But I don't want y'all to pay $23. So here's what y'all gonna do, all right? Y'all gonna look online, right? Shop around, Walmart, Amazon, whatever, you're gonna find a price that's lower than 23, right? When you find that price, you're gonna go to Staples, right? You're gonna show them like, yo, listen, on this website, they got it for this price, right? And they're gonna price match it for you, right? So if y'all find it for 10 bucks, then you're gonna pay 10 bucks at Staples to get it. That's simple. All right. This calculator is very powerful. There's so much that it could do. You know, I wish I had more time with you guys to show you everything, but I'm gonna show you the statistics stuff that it can do. So those of you that are in the future thinking about changing your major to engineering, this is the only calculator allowed on the fundamental engineering exam, just letting y'all know, right? Go ahead. Go ahead. Sure, sure. That one is a little bit more complicated and way more expensive. Way, way more expensive, you know? But yeah, if you have it, go ahead. No problem. Yeah. All right, so learning objectives, that's what I just went over with you guys. And then blah, blah, blah. This is fulfilling the pathways requirement for B, you know, all that good stuff. That's the book. Yes, that's the 8th edition. And then here we go. This is our syllabus right here. This is everything we're going to be doing for the whole semester, right? So these are the topics right here. These are the page numbers in that book, right? And these are the suggested homework questions right here. Your homework is not coming from here. Your homework is actually going to be in WebWork. I'm going to show you guys that in a second, right? But if you guys want like extra practice on top of the homework, be my guest, you know, you can knock those out. All right. So that's it in a nutshell. This is like the whole class, all these topics. And we have our homeworks here. I'm sorry? About 37%. I'm gonna get to that though. I'll get to that. All right. So academic integrity, right? Please do your own work. All right. Submit your own work. Try. All right. That's the best way I could put it. Try your best in the class. You know, I'm really encouraging you all to go to tutoring, right? But don't sit there in tutoring having the tutor do every single question for you guys. All right. Try it yourself. More likely than not, after you finish class, you can do the homework. More likely than not. I understand sometimes there might be 1 or 2 questions like, dang, but we did an example with a 4, but this one got an 8. How I do this now? You know, like I get it. You know, so like for like little things like that, you know, you could go to the tutoring and ask for that. But like don't have them do the whole homework for you. Because on the day of the test, they're not there next to you to help you. Right? So try it. Promise you it's a lot easier than you might think. Accommodations. If anybody is allowed accommodations, please just tell me in private, you know, what it is, and then we can plan it out. If you feel like you should have accommodations and you don't have it, right? This is the email right here, disability dot services at bcc.cuny.edu. They're located in Lowell Hall, room 211. That's like on the first floor where you just walk right in, just make it right. And then this is their phone number. All right. So if you need anything, they'll help you out. Right? Accommodations is like saying you get extra time or you're allowed a calculator on your test or whatever. Y'all already got calculators, but if y'all need like extra to make sure, you know, kind of thing, there you go. All right. So that's our syllabus. Again, I'm gonna post this on Brightspace a little bit later. All right. Let's see what else we're gonna get into. So when I told y'all the syllabus, gave y'all my email. Oh, I didn't tell you guys the times for tutoring, my bad. So Monday through Thursday, right? 11 a.m. to 8 p.m., right? Friday and Saturday, 12 p.m. to 6 p.m. That's the same time for online and in person. All right, so that's a time for tutoring over there. So you can definitely go there right after class because that's when they open. Let's go over the grade breakdown. I'm gonna post this online as well. So your final exam is gonna be worth 33% of your grade, right? We're gonna have 3 in-person tests over here, right? I'm gonna take the best 2 out of 3, and that's gonna be 30% of your grade, and the homework is 37% of your grade. All right. So that's our breakdown. I was not able to find the final exam date, so I don't actually know when that is, but when I know, I'll let you guys know later on. All right. Let's talk about homework real quick now. All right. So I am going to post this on Brightspace, but just to let you guys know, I'm gonna post the same message right here, right? So homework access. So homework can be found on BCC's web work page. If you go to the web work page, you just have to scroll down to 2024 Fall the Math 23 S01, right? If you like, you can click the link. These will be hyperlinks, so you can just click it if you don't want to scroll down on the page. To log into your homework, right? This is your login. Your username and your password, right, are both your first name followed by your last name with no spaces in between. So, for example, if my name is John Doe, my username will be John Doe. All lower cases, no space in between, just one single word, right? That's your username and your password for your homework, right? I mean, if you guys want to copy this down, look at y'all homework, y'all can. It's a whopping like 6 questions. That's it. I didn't have a chance to post everything to go ahead. No, it's gonna be on WebWork, but I'm gonna put the link to get to it on Brightspace. Yeah. I'm just like showing it in case anybody wants to like look at it right now. Like that's what it is. All right. So as I was saying today, we're just kind of trying to build some vocabulary a little bit, right? So that we can have a conversation about statistics, right? So in life, right, we all have to make decisions in life. And that's what probability and statistics is all about, right? So making a decision like between like let's say, I don't know, let's say cookies and ice cream, right? The answer is always both, right? Or let's say if we want to decide between Trump and Kamala, right? Or Math 23 or doing Math 28, right? All of that you can do using statistics, right? So statistics helps us to make informed, educated decisions in life, right? We make decisions based on the best information that we have, right? Statistics will help us to analyze that information in order to make an informed decision, all right? One of the most powerful uses I could say for statistics is the ability to take a small collection of data, sample, right? And then make an inference as to what the population is thinking, right? Let me give you an example for that, right? Let's say this classroom right here. Let's say I go around the classroom and I'm like, yo, listen, what you think about this election? What you think about this election? What you think about this election, right? I'm gonna collect all that data, right? Based on that data, I could say, you know what? I feel like the whole college feels like this class, for example, right? So that's the kind of stuff that we're trying to do with statistics, right? We in real life, we have access to samples, like small examples of how everybody feels or whatever, and we want to make a educated guess as to what the whole population feels. So yeah, um, real quick, I feel like feel like this definition says it a little bit better than I can, so I'm gonna share it with y'all. What is statistics? So right here, statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. Is podium blocking you, or you good? Y'all good? I don't have any paper on me. I'm so sorry. Anybody got a piece of loose leaf? If the lab was open, I'd have blessed you because they got mad paper in there. Next week, definitely, I got you. All right. So yeah, that's what statistics is, all right? All right. Said a little bit differently. All right. Statistics is both the science of uncertainty and the technology of extracting information from data. I feel like I don't even see the background here. It's supposed to be blue. I don't know if you guys can see that. Yeah. Again, today is just about definitions. Definitions. Huh? Huh? Oh, got you. No problem. So the general prerequisite for statistical decision making is the gathering of data. So first, we need to identify the individuals or objects to be included in the study and the characteristics or features of the individual that are of interest, right? Fun stuff, fun stuff. We're gonna have some good examples with that. Just building the vocabulary, right? All right, so let's talk about this. So individuals are the people or objects included in the study. A variable is a characteristic of the individual to be measured or observed, right? So individuals is who you're studying, variable is some characteristic of them, right? So for example, trying to think. Let's say I wanted to know how many people try to chop cheese in New York City, right? So as they're going in, I'm just like kind of tallying it off, right? You tried it, you tried it, you tried it, right? So that's the individual, the people that I'm studying, right? The people who actually try the chopped cheese, right? Now, each one of those individual people, they have different characteristics, right? So I could look at like their height, for example, like how tall is this person versus that person. I could look at their gender. Is it a guy or a girl? You know, I could look at what color their hair is, etc. Right? I could look at all different kinds of characteristics that they have and create a whole spreadsheet of data based off of that. Right, that would be the variable. All of those other things are variables. The individual person that's trying to chop cheese, like that's what I'm studying. Yeah. So that's that. Speaking of variables though, right? I wanna let y'all know there's two kinds of variables now. So we have quantitative variables, numbers, and then we have qualitative variables, right? So for example, let's say I'm looking at their height, right? So height is a number, right? You 5'6", you 6'9", whatever, right? If I'm looking at, let's say, their eye color, for example, I don't know why that matters, but let's say I'm looking at their eye color, right? Eye color is not a number. That's right. That's quantitative, right? So let me just give y'all the definition for that real quick. Now, when you guys like start your majors, y'all gonna encounter these terms, right? These types, excuse me, of variables that you're studying, right? So a quantitative variable has a value or numerical measurement for which operations such as addition or averaging make sense. Qualitative variable describes an individual by placing the individual into a category or group, such as male or female, tall or short, you know, blue eye, green eye, red eye, etc., etc., etc. Right? And if you're wondering, do people study like weird things in statistics? Yes, they do. Yes, they do. Right? Like, what's something weird that I know? So, like, apparently pirates is a real thing, right? Like, people actually go on ships and be stealing other people's stuff and whatnot. But apparently, they only like to do that when the weather's good outside. Makes sense, no? That's the kind of stuff they study in statistics, you know? All right. So again, like height in our previous example, that would be quantitative, right? Versus eye color would be qualitative, right? Another situation that we want to discuss in statistics, right, is what kind of data are we looking at, right? Are we looking at a sample of data or are we looking at the whole population, everything, right? So let me just give you those definitions real quick, right? But since we have the idea of what an individual is in a variable, right, just kind of building off of it, right? In population data, the data are from every individual of interest, right? So back to the chopped cheese example, right? That's everybody that's trying to chop cheese, right? Not just here, talking about like the whole college, for example, right? In the sample data now, right? That would be only like, let's say, the people in this room, right? So I can take a poll based on the people in this room, and then I can make a educated guess as to what the whole college might feel about the chopped cheese, right? Yeah. I don't know why chopped cheese just came to mind, but it just did. I guess I was hungry when I was doing this. All right. Something important to mention about this, right? Data from a population is always fixed. It does not change, right? And it is complete. While data from a sample is not complete, right? And it can vary from sample to sample. So for example, like let's say I just surveyed these three people here, then I surveyed these two rows here, and so on and so forth, right? It might change, like everybody here might like the chopped cheese, and there might be a large group over there that's like, nah, it's not for me. That's fair, you know? So when you have a sample, like right, you sometimes you'll hit the nail on the head spot on, and sometimes it might vary a little bit from what the overall population feels for someone. Right, right. It depends on where you take your sample from, you know? It let's see. I don't know if change the answer is it is skewed, yes. I don't know if change the answer is the right way to say it. Like it it has bias in it, right?
Like if you take all the salary of like your city.
Exactly. And you have some super millionaires living here, they just throw it over. It changes your information, right? So after you do the little easy statistics that you're gonna do, right? Let's say like in your particular major, what's gonna happen is that you might have to write a report about what you found, right? So in that report, that's where you get to be authentic and say like, listen, I got my data like this, like this is the samples that I took, It's possible that the samples are plus or minus in range, you know? Because more often than not, it's gonna be really, really hard to get like a population study. Unless you're a bio major studying like germs or something in a petri dish, like you ain't gonna have the population at your disposal, you know? So it's just too big, it's too broad, you know, but with a large enough sample, you can make an educated guess as to what something is gonna be. In medicine, for example, I don't know if anybody here is doing nursing, right? Like you want to administer medication to a patient, you're not going to give that medication to everybody in the whole world and figure out what it does or doesn't do, right? You're going to take a small study of people who have that particular condition that the medicine is supposed to treat, right? And if it works out good in that little study, right? And by little, I mean like 10,000, right? Like then you can make an educated guess that, all right, in the population, it'll probably help someone who, I don't know, has whatever condition that it is that the medication is treating. You know? Just for example, you know, just throwing that out there. All right. Another good example that I have is let's say like this upcoming election, right? Let's say I ask everybody here how they feel about the election. And let's say I go down the road, I go down to Fordham University and ask them how they feel about the election, right? Might be some bias there, you know, between us versus them. You know, I mean, Trump graduated from there, right? So we go to bias right there. So yeah. So I'm not going front. If one of y'all was running, I'll be like, nah, that's BCC right there. Oh man. All right, let's talk about this. Let's talk about parameters and statistics real quick. So a population parameter is a numerical measure that describes an aspect of a population. A sample statistic is a numerical measure that describes an aspect of a sample, right? So more often than not, right, I only have access to sample statistics, right? But in general, I don't really care about that. I care about parameters. I want to know what everybody think, what everybody feels, you know? So I work out my little sample. I make my inferences, my guesses, my educated decisions onto what the population might be, right? You guys see this every day when you guys watch TV. Matter of fact, I'll bring up something. I was watching the news, I want to say last night, I think. Yeah. They have a new hurricane that's supposed to be heading to the Caribbean, right? So you guys ever see those hurricane maps and then they have one line is here, there, this, all of that, right? Or all of those different lines right there. All of those lines are samples, right? They don't know where it's gonna go, but they think it's gonna go somewhere. This general direction kind of situation, right? So like that's an idea of what it is. What I'm really interested in though is the parameter, right? Like where is it exactly going? You know, so I could know to like cancel my vacation and go to the other island, you know, stuff like that. Yeah. Yes. Yes. Thank you. Thank you. I'm just thinking out the box, you know. Um da da da. Let me give you guys another concrete example. This one's going to be written out so you guys can visually see. We're not just talking stuff. So the Hawaii Department of Tropical Agriculture is conducting a study of ready to harvest pineapples in an experimental field. Cool. The pineapples are the object or the individuals of the study. If the researchers are interested in the individual's weights, like say the weight of the pineapple in the field, then the variable consists of weights, right? So at this point, it's important to specify units of measurement, right? So that's one example. I got more, don't worry. Because it all makes sense with the examples, you know? And again, we just building vocabulary, so no adding and subtracting today. It's okay if you don't have your calculator today. We'll get to that next time. All right, and degrees of accuracy of measurements, right? So the weights could be measured to the nearest ounce or gram, right? Weight is a quantitative variable because it is a numerical measure, right? If weights of all the ready to harvest pineapples in the field are included in the data, then we have a population. The average weight of all the ready to harvest pineapples in the field is a parameter, right? Now, suppose the researchers also want data on the taste of the pineapples, right? A panel of tasters rate the pineapples according to the categories of poor, acceptable, and good, right? Only some of the pineapples are included in the taste test. In this case, the variable is taste. This is a qualitative or a categorical variable. Because only some of the pineapples in the field are included in the study, we have a sample, right? So the portion of pineapples in the sample with a taste rating of good is a statistic, right? So those of you that might be studying psychology, I don't know if anybody's in here doing that, right? This is the kind of thing you're going to deal with a lot. These qualitative kind of variables, right? How do you feel? When you woke up, like was the sun up or was it down? You know, those kinds of things, right? And then based on that information, you can make informed decisions that can help your client. All right. That being said, let's talk about different levels of measurement, right? So these levels of measurement, right, enable me to do certain types of arithmetic on the data that is in front of me, right? Such as ordering the data, right? Say from smallest to largest, taking a difference of the data, like subtracting one value from the other, or even taking a ratio of the data, right? So just want to show you guys the levels of measurement. And you will see this in your homework, don't worry. The homework is literally just examples, and you're just saying like, oh, this is that, and that is that. That's all it is. All right. So we have levels of measurement. Let me just pull this down in case anybody was copying. So the nominal level of measurement applies to data that consist of names, labels, or categories. There are no implied criteria by which the data can be ordered from smallest to largest, right? So let's say I'm talking about the boroughs, right? So you got like Bronx, Brooklyn, Manhattan, Queens, etc., right? They're just names, right? Like if I put like Brooklyn before Queens or something, you know, it doesn't really matter, right? But I can order them, let's say from alphabetical order or something, but it's meaningless which one I put before the other, right? But we all know that Bronx always comes first, right? Yeah. All right. Then we have ordinal levels of measurement, right? So the ordinal level of measurement applies to data that can be arranged in order. However, differences between the data values either cannot be determined or are meaningless, right? Give me an example of ordinal now. Let's say you guys go to like the store and y'all want to shop for like a t-shirt, right? You know how the t-shirt comes in different sizes. You got like small, medium, large, extra large, etc., right? That's ordinal right there. So we could order it from like small to large or whatever, right? But it doesn't mean anything. Like if you put large before medium and stuff, it's the same thing, you know? Yeah. So that's ordinal right there, right? Interval. Now we're getting interesting right here, right? So interval level of measurement, right? So that applies to data that can be arranged in order. In addition, differences between the data values are meaningful, right? So if I talk about the temperature 2 days ago, yo, it was like 100. Y'all believe that? I'm sorry. Yeah, like a couple days ago it was like 100. Today I think it's like what 70 or 60. I didn't even check. I didn't even ask Alexa this morning. But, like, yeah, see how we have those different numbers, those different temperature amounts? Like that's an interval, right? That would be an interval. Ratio. Ratio is very, very similar to the interval, right? So the ratio level of measurement applies to data that can be arranged in order, just like the interval. In addition, both the differences between the data values and the ratios of the data values are meaningful, right? And the data at the ratio level has a true zero, right? So basically everything else that ain't temperature, the ratio, right? So we're talking about like height, nobody is like true like 6 nothing. Like y'all got like 6 and a couple centimeters or something, right? Ratio. When you hear like decimals coming into the conversation a little bit, that's the ratio right there. Decimals, fractions, that kind of thing. Yeah. And you can also it has a true zero. The zero. Yeah. Interesting. Some let's say early groups of people, they didn't even understand what zero was.
No.
You know?
I know that wasn't really a common concept.
Yeah.
Yeah,
I found that really interesting. Like y'all didn't know what that. Yeah, it was no, they were the ones that came up with zero. I want to say it was like the Greeks and stuff. They didn't know what zero was.
Right.
This was really interesting.
Yeah, I was asking like it was the Mayan concept.
Yeah, it was really cool. Not gonna lie. But speaking of which, just for fun, let's identify the type of data that this is. So y'all gonna have to help me out. Taos, Akuma, Zuni, I don't even know how to say that one, so I'm not even gonna try. Are the names of 4 Native American Pueblos? Pueblos. Okay, from the population of names of all the Native American Pueblos in Arizona and New Mexico. What type of data is this? Would you guys say nominal, ordinal, interval, ratio? Nominal, right? Very good. Yeah, I already needed y'all help on that one. Like I was sinking there. I was sinking there. All right, let's try another one. Whoops, my bad. 1 second. All right, let's try this. So in a high school graduating class of 319 students, Jim ranked 25, nerd. June ranked 19th, super nerd. Walter ranked 10th, and Julia ranked 4th. Yeah, that's an Ivy League school. All right, so where 1 is the highest rank, what kind of level of type of data is this? Say it again. Interval. Very good. Very good. Oh, sure. You want to see the definitions?
Yeah.
Got you. There you go. Not interval, ordinal. Because they're ranks, right?
They're different beings.
Right. Mhm. We good? I can go to the next example. So B is ordinal, all right? How about this? Body temperatures in degrees Celsius, right? My chemistry major's in the room. Of trout in the Yellowstone River. What do we think? Say it again. Interval, right? Anytime you hear temperature, interval, all right? Temperature, weather, interval. All right, last example. Interval. Last example. Let's say that we want to know the length of trout swimming in the Yellowstone River. So we want to know like how long is the fish? You know, what level of measurement would you say that is? Oh, no. It's a length. Ratio, right? Because like remember, like I said, with your height, nobody is like true 6'0", right? Everybody's like a couple centimeters off or whatever. Yeah. Yeah, it does. Say it again. I'm sorry. You could think of it as a ratio. Yeah. Anytime you see temperature, interval. Yeah. So I kind of want to give you guys a little procedure real quick. So, try and make this real nice. Put that up a little bit. All right, so procedure, how to determine the level of measurement. So the levels of measurement listed from lowest to highest are nominal, ordinal, interval, and ratio. To determine the level of measurement of data, state the highest level that can be justified for the entire collection of data. Consider which calculations are suitable for the data. So let's take a look. Level of measurement, right? Suitable calculation. We can put the data for nominal, excuse me, we can put the data into categories, right? That's one way to tell, like, okay, that's a nominal situation, right? Ordinal. We can order the data from, say, smallest to largest, worst to best. Each data can be compared with another data value. That's for ordinal, right? For interval, here we go. We can order the data and also take the differences between the data values, right? At this level, it makes no sense to compare the differences between data values. So for instance, we can say that one data value is 5 more than or 12 less than another data value, right? And then ratio, we can order the data, take differences, and also find the ratio between the data values. For instance, it makes sense to say that one data value is twice as large as another, right? So this is kind of how you can identify what's going on, right? What level of measurement it is. All right. So that being said, right? Let's get back to that conversation about statistics, right? There's two kinds of statistics that we're going to talk about. Well, there's only two that exist, right? So we have descriptive statistics, right? Which involves methods of organizing, picturing, and summarizing information from samples or population. Then we have inferential statistics, which involves methods of using information from a sample to draw conclusions regarding the population. All right. That being said, let's talk about our tests that we're gonna have in the class, right? So remember I said that we're gonna have 3 tests in the class. Test 1 is gonna be descriptive statistics, right? Test 2 is gonna be the first half of inferential statistics, which is kind of like we're just building a toolbox a little bit on that second test, right? So that we could do the real inferential statistics on the third test, right? And that's how our class is basically broken up, right? So if you have the book, this is like test 1 is going to be like chapters 2, 3, and 4. Test 2 will be like chapters 5, 6, 7, and then test 3 would be 8 and 9, right? So that's it in a nutshell. What? Yeah, yeah. I just didn't have time to upload it to Brightspace and all that. I mean, this part I'm not putting there. This is recorded, but but I'm gonna put the recording there so you can like click the link and watch it. All right, cool. So now that we got some vocabulary under our belt, right? Let's talk about samples, right? Since rarely in life we have access to the population outside of biology, lucky them, right? Let's talk about samples. I want to talk about random samples, all right? And in particular, I want to talk about the different techniques that we have to get a sample, all right? All of the examples that we're going to run through in this class, they're going to be simple random samples, right? But I do want you guys to know that other sampling methods exist so that when you guys go on to the 4-year school and stuff and you take your next statistics class, you guys can see or at least be able to understand what it is they're doing, right? So real quick, I just mentioned the word simple random sample. Let me give y'all a definition of that real quick. All right. So a simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. Right? So that's a simple random sample. Just randomly choosing an individual, right, to be in my study. And yes, there can be bias in my choice as well. That's another issue that we have. All right. So in a simple random sample, not only does every sample of the specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply a simple random sample. Remember, for a simple random sample, every sample of the given size must also have an equal chance of being selected. All right. Important things to mention about it. So important features of a simple random sample. For a simple random sample, every sample of specified size n from the population has an equal chance of being selected. No researcher bias occurs in the item selected for the sample. A random sample may not always reflect the diversity of the population. For instance, from a population of 10 cats and 10 dogs, a random sample of size 6 could contain all cats. That is legal, right? So that's what I was saying. Like if I was to ask over here how they felt about chopped cheese and then next 2 rows and so on and so forth, it might vary from sample to sample, right? Yeah. I don't know. Chopped cheese is a conversation today. Yeah. Y'all know that the deli over here is fire. They do the chopped cheese right across the street. And they halal, which is fire, you know? Yeah. Savant. All right. So as I said, most of the samples in our class are going to be random samples, right? But I do want you guys to know some of the other sampling techniques that exist. All right. So the first one I want to talk about is called stratified sampling. For me, this is just more about building your knowledge so that when you go to your next class, like everything will make sense. You know? So stratified sampling. Groups or classes inside a population that share a common characteristics are called strata, plural from stratum. For example, in the population of all undergrad students, some strata might be freshmen, sophomores, juniors, and seniors. Other strata might be men or women, in-state students or out-state students, and so on and so forth. In the method of stratified sampling, the population is divided into at least two distinct strata. Then a simple random sample of a certain size is drawn from each stratum, right? And the information obtained is carefully adjusted or weighted in all resulting calculations. So the groups or stratas are often sampled in proportion to their actual percentages of occurrences in the overall population. However, other more sophisticated ways to determine the optimal sample size in each stratum may give the best results. So in general, statistical analysis and tests based on data obtained from stratified samples are somewhat different from techniques discussed in an introductory course in statistics, right? So basically, I have a population and I'm gonna group certain people in that population into certain groups. And then from those groups, I'm going to take the same number of people from each one randomly. And then that's going to be my individual that I'm studying. All right. It's just another way of sampling. We're not going to do it in this class, but I want you guys to know about it. Your major might be doing things like this, by the way, you know, your individual majors. Right. Another popular method of sampling is called systematic sampling. Right. And this method is assumed that the elements of the population are arranged in some natural sequential order. Right. Then we select a random starting point and select every kth element of our sample. So, for example, let's say people are lining up to buy a rock concert tickets. No, hold up. Oh, that's wrong right there. It's not supposed to be rock concert, right? Taylor Swift, right? Yeah, there we go. Now it's right. So we got people lining up to buy Taylor Swift tickets, right? And they're in order, right? So to generate a systematic sample of these people, right? And ask questions regarding topics such as age, smoking habits, income level, etc., we could include every fifth person in the line. So the starting person is selected at random, and after that, every fifth person is taken to make up our individual that we're going to study. Right? So that's systematic sampling. Now, there is an advantage to doing this. Let's talk about that. So the advantage of a systematic sample is that it is easy to get, right? It's real easy to get that data. However, there are dangers in using systematic sampling when the population is repetitive or cyclical, right, in nature. Systematic sampling could not be used. For example, consider you have like a fabric mill that produces dress material. Suppose the loom that produces the material makes a mistake every 17th yard, but we only check every 16th yard with an automated electric scanner, for example. In this case, a random starting point may or may not result in the detection of the fabric flaw before a large amount of fabric is produced, right? So, for example, right? How many people like watch the news and then all of a sudden it's like, yo, we got to recall all this food because such and such thing happened to it and blah, blah, blah. What were the food people doing? Systematic sampling. That's why they messed up, right? In a nutshell. Oh, with the systematic sampling? Listeria with the boar's head thing. Yeah, that outbreak is crazy. I totally stopped eating deli sandwiches after that, man. Yeah, yeah. But the listeria outbreak, like, is this? You know, like they're picking every other order or something like that, and because of it, it's like some of it is slipping out into the population, and people are getting sick and dying and all of that. You know, I miss my turkey sandwich. I ain't gonna lie, man, right? Turkey was the bomb, man. But now I'm on that grilled chicken, that tuna. You know? Yeah, I'm gonna give it like a year or so for Listeria to break, to stop doing what it's doing. All right, let's talk about another sampling technique, right? We have cluster sampling. All right. So cluster sampling is a method used extensively by the government agencies and certain private research organizations. In cluster sampling, we begin by dividing the demographic area into sections, right? Starting to sound like politics, right? Then we randomly select sections or clusters. Every member of the cluster is included in the sample. For example, in conducting a survey of school children in a large city, we could first randomly select 5 schools and then include all the children from each selected school in the study. All right. So, long story short, I want to know what the Bronx feels about this election, but it's impossible for me to go to everybody and be like, what do you think? What do you think? What do you think? Right. So with the clustering sample, right, I could break it up by, let's say, zip codes, right? And then within every zip code, I can include all those people in the study, right? Now that I thought about it, that's really a bad example because that's including everybody. Right? That's the that's the thought process here, you know. And this is why like MSNBC, CNBC always get their stuff wrong and all that. It's where they take their samples from. That's the truth. Is where they take their samples from. Whoops. Ooh, I made a mistake. 1 second. All right. Sorry about that. So often, a population is very large or geographically spread out. In such cases, samples are constructed through a multi-stage sampling design, right? This is our last sampling technique of several stages. Within the final stage consisting of clusters, for instance, the government current population survey interviews about 60,000 households across the United States each month by means of multi-stage sampling design. For the current population survey, the first stage consists of selecting samples of large geographic areas that do not cross state lines. These areas are further broken down into smaller blocks, which are stratified according to ethnic and other factors. Stratified samples of the blocks are then taken. Finally, housing units in each chosen block are broken into clusters of nearby housing units. A random sample of these clusters of housing units is selected, and each household in the final cluster is interviewed. Cool, right? This is redlining at its best. I don't know if y'all ever studied that, but that's where all this nonsense comes from. You go to the bank, you get a certain type of rate based on, you know, y'all get the gist. Well, my fault. We have another one, convenience sampling. My fault. Convenience sampling simply uses results or data that are conveniently and readily available, right? So in some cases, this may be all that is available, and in many cases, it is better than no information at all. However, convenience sampling does run the risk of being severely biased. For instance, consider a news person who wishes to get the opinion of people, right, about a proposed seat tax to be imposed on tickets to all sporting events. The revenues from the seat tax will then be used to support the local symphony. The newspaper stands in front of the concert hall and surveys the first 5 people exiting after a symphony performance who will cooperate. This method of choosing a sample will produce some opinions and perhaps some human interest stories, but it certainly has bias because, of course, all of them want their symphony to get all the money, right? It is hoped that the city council will not use these opinions as the sole basis for their decision about the proposed tax. It is good advice to be very cautious indeed when the data comes from a method of convenience sampling, right? So I'll give you an example. Let's say that you want to run an experiment, right? But you don't have the funds, you don't have the ability to run a survey and gather all the information and stuff, but somebody else did a similar topic in what you're interested in speaking in. You could take their data set, right, analyze it, and then make your predictions, your write-ups about whatever, right? That's convenience sampling right here, right? You're just taking what they want, or let me see what they have, and then you're using it for your advantage, right? The person that ran the experiment, you're at their mercy, right? Like, did they do it in an honest and faithful way? Did they do it in a way that benefits what you need it to talk about? No? Good. Exactly. Exactly. You know, sometimes the data that they're studying is bias itself. You know, that's actually an issue that we have in AI, to be honest, because the data that's fed it is not good. You know? All right, just want to recap a little bit. All right, let's recap a little bit. So sampling techniques, we have random sampling, right? That's when you use a simple random sample from the entire population. Stratified sampling, that's when you divide the entire population into distinct subgroups called strata. The strata are based on a specific characteristics such as age, income, education level, and so on. All members of a stratum share the specific characteristic. Draw random samples from each stratum. Systematic sampling, number all members of the population sequentially, then from a starting point, select that random every kth member of the population in the sample. Cluster sampling, divide the divide the entire population into pre-existing segments or clusters. The clusters are often geographic. Make a random selection of clusters, include every member of each selected cluster in the sample. Multi-stage sampling, use a variety of sampling methods to create successfully smaller groups at each stage. The final sample consists of clusters. Convenience sampling, create a sample by using data from population members that are already readily available. All right. How's everybody feeling? Y'all good? But you're gonna have a formula sheet. We're gonna do that next week though. I'm gonna show y'all. Yeah. Y'all have y'all calculators and y'all have the formula sheet. That's all you need. Like literally the answer to the whole test is right there. know?
Is there one with a guide on how to use the computer?
Sure, yeah. I mean, I'm gonna try and show the calculator as much as I can in class. If I don't get to it, I strongly recommend you guys go to tutor and ask the tutors how to use your individual calculators. You know? Yeah, please, if you could. Yeah. That way, if you have any questions, I could address that in class, and if I don't get to it, then in tutoring, you know, we can go there and hash out anything. Right? Yeah. I'm sorry? Yeah. I'm gonna post that. Yeah. I haven't figured that out yet, what day it's gonna be, but it'll be posted on Brightspace. Yeah. Just a test. That's all we're gonna have. We're just gonna have the three tests. No, three tests and then the final. That's it. Yeah. But homework though, like do your homework. Definitely, I'll always do that. Yeah. No, it's on WebWork. You literally just type in the answer, click enter. Yeah. Yeah, you submit it online, basically, yeah.
Exact, percentages of our total test 33. Well, final 33.
Finals 33,
And our 37.
37
Is allocated.
is 30 yeah,
Patient.
for the test. That's it, yeah. No, that's it. Yeah. Oops, I don't know what that was. All right, let's continue real quick. So we call the list of individuals from which a sample is actually selected the sampling frame. Ideally, the sampling frame is the entire population. However, from a practical perspective, not all members of a population may be accessible. For instance, using a telephone directory as the sampling frame for residential telephone contacts would not include unlisted numbers, right? So when the sample frame does not match the population, we have what is called undercoverage. So in demographic studies, undercoverage could result in if the homeless, fugitives from the law, and so forth are not included in your study, right? Just giving you an example. Undercoverage. All right, so in general, even when the sampling frame and the population match, a sample is not a perfect representation of a population. Therefore, information drawn from a sample may not exactly match corresponding information from the population to the extent that sample information does not match the corresponding population information. We have an error called sampling error, all right? These things happen, they happen all the time. Right. Give you guys a little definition real quick. So a sampling error is the difference between measurements from a sample and corresponding measurements from the respective population. It is caused by the fact that the sample does not perfectly represent the population. A non-sampling error is the result of poor sample design, sloppy data collection, for faulty measuring instruments, biased in questions, and so on and so forth, right? So let's say everybody in this room loves chopped cheese, and then I just went off of that and I said, all right, definitely the whole room loves chopped cheese because these three people over here, they love it, right? That's sampling error right there, right? And then non-sampling error You know, like that's also over here, like I'm just focusing on one thing, right? I'm not surveying multiple groups to make a generalized statement about what's going on. Right? I'm just kind of like doing a small little group and just saying, okay, based on what they said, that's facts, and that's it. You know? All right. Sampling errors do not represent mistakes. They are simple. Wait, excuse me. Sorry about that. I wanted to pull that down. They are simply the consequences of using samples instead of populations. However, be alert to non-sampling errors, which may sometimes occur inadvertently. All right. That's it for today that I have. That's all the definitions. Right? You guys can keep copying. I'm gonna try and go on Blackboard, Brightspace, and post all the stuff that I said I was gonna post. I mean, if you guys want to stick around and try out homework, go right ahead. No problem. I don't have one on me. I'm an Android user. That's why everything is so slow around me. I mean, if anybody else got an iPhone charger though. We got mad outlets. One of them is for also over here, all them chemistry tables, they got outlets too and all that. There's mad outlets over here. All of those work over there on the yeah. You see them? I know it looks weird, but they got them right there. No. Look, you see where the sink is? That black thing over there, you see it going run across and all that? Yeah. I don't know. It's an old room. It's an old room. It's back in the day. Yeah. I'm sorry? Just do it by the first test. Let's say 4 weeks from now. Yeah. 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 I haven't worked all the logistics out, but yeah, I'm gonna tell you on Brightspace. Yeah, you can go if you want. Unless you want to stay and do your homework, I mean, go ahead. Yeah, I'm cool. I'm just trying to post the link online right now for you guys. So cool. Go ahead. No, you fine. Oh, no worries.
Nobody ever told me how to talk over the app. I have
There is an app for it.
I don't know if they're planning to do that. That's the thing, but if y'all want to play some more, I
Absolutely.
Yeah, hold. Get that pulse right there. That's part of it. All right. Well, actually, everything you need is like, to be honest with you. Those another thing you should download though. They also got the BCC app. It always happens to me. He always comes out and trying to double C. It's not like you get this right here. So when you get this now, right? Like you know, like how you have the ID that they gave you. That the ID is right there, so you don't gotta walk around with the ID. And then also it has like the bright spaces there as well. As long as well as like other clubs and activities on campus. You know. Okay, so you just log in the same way that you log in for your email. You know. So first name dot last name.
They ain't telling me about
Did he give you all that? Okay, so I'm saying
I gotta go to the office or something.
Yeah, so you know where you got your ID, right?
State should be. They give me nothing.
I got you.
Yeah.
So you gotta go to Roscoe Brown. Do you know where Roscoe Brown is? I'm trying, I wanna let me get a map real quick.